Hello everyone. Today we are with plant-water relationship. We are trying to understand it. Why we are trying to understand plant-water relationship? We know water is very important for plant and us, but we are trying to understand water potential, TPD. Why? See, we have studied short distance transport. What are the short distance transport? There are four types of transport: solute, osmosis, simple diffusion, facilitated diffusion, active transport, and then cytoplasmic streaming. And then we also have long distance transport. And to transport, we transport water, and we should know about the mechanism of short distance transport, and that is what through we can understand plant water releasing water potential. So, what is this diffusion? Movement of molecule from higher potential to lower potential. So we have to understand what is it moving from higher potential to lower potential. We have to understand water potential. Cut it thoda sa. Let's manage it. We have to understand what is water potential. What is moving from higher potential to lower potential. So we have to understand it, right? So we are trying to understand that concept. So now I'm just doing crisp. We are going crisp. So these are the symbols to represent water potential, solute potential, and pressure potential. Actually, my mistake. Pressure potential, and the unit is Pascal. So can you see that there we are talking about the potential energy, but we are writing unit Pascals. Yes, that's why we have to look something else. So, but just look at here that we are trying to understand the energy. So anything which has higher potential, molecule move from higher potential to lower potential. That's we know. This is our basic, and I'm not going to explain that basic. Okay, 10वीं क्लास में पढ़ी होगी actually तुमने. So I'm not going to explain that. That's really basic. Let me explain. Okay, but I will explain now. There are two beaker. This is full of water and this is empty. What will happen? This is high potential. यहाँ water ज़्यादा है, यहाँ water नहीं है, तो water move from here to here. That's it. We are trying to understand. Oh, Ujala. So that's it. We are trying to understand the water potential. That water move from higher potential to lower potential. That is the concept actually. This has energy, higher energy. How we have energy? Minus mgh. You have studied in physics. So it has potential energy. High touch. Okay, understood? And all the potential energy should have negative values. Why? Because the potential energy always have negative values. Now, so first let's look at the water potential. Water potential energy of water molecule. That's we have seen energy of water molecules. More water molecule, more the energy. That's a common energy of water molecule. The more will be water molecule, more will be energy. So water potential should be directly proportional to concentration of water. More will be concentration of water, more will be water potential. So, and this we talked about move from higher to lower. And pure water can have maximum water potential. Why? Because it has more water. It has only water, and that is zero. Maximum water potential 0. Water potential can have values positive, that is 0. But when we add solute, it becomes negative. Decrease the water potential. And now, concentrated solution has low water potential because it has low water concentration solutions. And dilute solutions has more water, so higher potential, high water potential. Now we have understood water potential, and now we are going to understand solute potential. What is solute potential, right? And the relationship between water potential and solute potential and pressure potential. And now let's look at it, solute potential. Let's look at the diagram. Look in the diagram. This is water molecule and this is sugar molecule. I did some sugar molecules. To dissolve these sugar molecules, I need some energy. Where does this energy will come? This energy will come from the solution itself. The sugar molecule will absorb some energy from solution and will get dissolved. So it's decreasing this overall energy of this solution, energy of the system. So water potential for the pure water was 0. I did some solutes and it became negative. Why? Because to get dissolved, it needs energy, and it's absorb energy from solution and make it negative. So what is solute potential? What is solute potential? Amount of water potential what is decreased by adding solutes, and this is always negative. And solution, what is this? Note this point, the solution is made of solvent and solute. We can take an example, that this is water and this is sugar. Okay, with that we have taken here. So if there is a solution, there should be solute, and solute always have negative water potential. So all the solution in the universe has negative water potential. Important point. And now let's look at pressure potential. Now we are trying to understand the pressure potential. To understand the pressure potential, let's look at the diagram again. There is a solution, and I am trying to press the solution through some extra pressure. So what will happen? The volume will decrease. And these molecules will get closer. Okay, so these molecules get closer, and the collision between the molecule will increase, because the molecule is now much closer and compact and close to each other. So higher will be collision, higher will be energy. So the water potential energy will increase. Energy will increase due to collision. So water potential, solute potential increase the water potential. So this is positive value. So we have seen that solute potential make it negative and water potential make it positive. So water potential depend upon both solute potential and pressure potential, and this is that our formula here has been derived, that we have now understood right now. Okay, so what we have seen, by applying extra pressure more than atmospheric pressure, it will decrease the volume of the solution and increase the collision, which lead to increase in energy, and water potential will increase. So now you can have question that we always have atmospheric pressure, but understand it, bro, that atmospheric pressure, let's take we always have atmospheric pressure. So atmospheric is constant, and all solution have that atmospheric pressure. Okay, so if this solution, chal ja yaar, this is not okay. Now if I have to do now, look at it, both have one atm pressure, both has one atmospheric pressure. Okay, atmospheric pressure, both has one atmospheric pressure. So here the same pressure is being applied, and here the same pressure is being applied. Sorry, the marker is dying right now and I can't do anything. So we have understood solute potential, pressure potential, water potential, and water potential is very necessary for diffusion, short distance transport. Now we can understand पानी किधर से किधर जाएगा, right? And all have units Pascal. But the problem is that we are talking that these are energies and we are writing unit pascals. Can we not get a formula where everything is in pressure and unit is also Pascal, that is pressure? So we can get that. And now let's move on to the next part of the NCERT. That's NCERT covered about that is that this pressure can be built through internally. आपने ऊपर से pressure लगाया, but internally can be formed? Yes, definitely. And now we will look on it, how it will be, and you will love the DPD part, and it will be now easy that we have X and we have understood